Okay, we're going to be doing lead code 441, arranging coins. It's an easy, but this is actually a tricky question because it involves math, right? So doing it, it has three solutions. One is in n time, one is in log n time, and then one is in constant time, right? But um, doing it in n time, Facebook or one of these companies isn't going to want you to do it in n time. They'll want you to do it at least in log n time, right? So you're given n coins and you want to build a staircase with these coins, right? The staircase consists of k rows where the ith row has exactly I coins. The last row of the staircase may be incomplete. So given the integer n, return the number of complete rows of the staircase you build. In other words, if you're given these coins to build a staircase, you need to return the number of complete rows. So here you're given 5 coins, right? In this example, you're able to fill up the first one, the second one, and you're not able to fully fill up the third one, so you return only 2 staircases, right? The way you do this is you need to know 2 things. The first one you need to know is the number of possible staircases, right? And the number of possible staircases given n coins. Let's first draw up what the staircases means. So the staircase at position 1 is going to be just 1 like this. The staircase at position 2 is going to be 2. The staircase at position 3 is going to be like this. The staircase at position 4 is going to be like this, right? So if you're given 1 coin, how many staircases can you make up? 1. If you're given 3 coins, how many staircases can you make up? 2. If you're given 6 coins, how many staircases can you make up? 3 staircases, right? The number of, if you're given coins, right? The maximum number of staircases will be, less than or equal to the number of coins, right? That's the first thing you need to realize. The maximum number of staircases you can build with, say, 5 coins will be less than or equal to 5, right? So which means the staircase we're looking for, right? If we're given n coins, the staircase we're looking for is between 1 to n inclusive, right? Because the reason why it's inclusive is because if you're given 1 coin, then you can only make 1 staircase, right? So that is the first thing you need to know. And once you figure this out, you realize it's a binary search. So now that we know that the number of stairs is going to be 1 to n, how do we know the number of coins needed to fill up each number of stairs? And this is where we use Gauss's formula for summation, or the sum of n numbers. And Gauss's formula is given up to n, the sum of numbers from 1 to n is n into n plus 1 divided by 2. Why is this helpful here? It's because the number of, let's first call them stairs, right? But we're substituting it for coins. 1, 2. The number of stairs, here we're calling them coins, needed to create 1 stair is 1. And why is that? It's just the summation, right? So it is if you're using Gauss's formula, which is n into n plus 1 over 2, it will be 1 into 1 plus 1 divided by 2. This evaluates to 2, cancels out with this, and you get 1. This is all the stairs you need to create one. If you need to create 2 levels of stairs, you'll need 3 coins. And how do we know this? It is 2 into 2 plus 1, which is 3, divided by 2. This is 3 stairs, as you can see. If you want to create 3 levels of stairs, you need 6 coins. And why is this? Because again, we use Gauss's formula. 3 into 3 plus 1 divided by 2 will be 3 into 4 divided by 2, which gives us 6. What is this 6? All these. So when we are binary searching from 1 to n, at each level we can know the number of coins needed to build the stairs up until that point, right? So that's where we use Gauss's formula. Right? So let me write the code, and then we'll come back and trace it out, right? Okay, so the maximum number of stairs we can build using n coins is n, right? So the stairs we can build using n coins is between 1 and n. That's the first thing you need to know. So our I will equal to 1, our j will equal to n. These are our 2 pointers, right? We initialize 2 pointers, right? Now we binary search to find the number of stairs. So while I is less than or equal to j, we calculate a mid, right? So we get a midpoint somewhere between 1 and n, right? So this mid will equal to I plus, in brackets, j minus I divided by 2, which we could have optionally written as I plus j divided by 2. So now we found a mid estimate for the number of stairs. Now we calculate the number of coins needed to build mid number of stairs. So number of coins is equal to, remember, we use sum of n numbers formula, aka Gauss's formula, right? So the number of coins will be mid into mid plus 1 divided by 2. Don't forget to put the multiplication here, right? So now we check if num coins is equal to n, then we've found n number of stairs can be filled with n coins, right? So if num coins is equal to n, then we can create n stairs with num coins. So we return the mid, because it's the mid that we used to calculate num coins, right? And this will work when n is 1, right? Because this will evaluate to 1 and you'll get. So if num coins is less than n, then we want our ith pointer to move forward. because it means the number of coins we have is not enough to build up to n, right? And the reason why we move our I pointer, because we want our end pointer to reach the closest, right? We want our I pointer to move down here, and then our j pointer to move here. We want once we're done with this binary search, our j pointer should be at the maximum filled row, in case we cannot find this portion. So, oh crap. So, else, this means our num coins is greater than n, and our j is equal to mid minus 1, right? So if we return this, it means that we had enough coins to fill up to n, right? Otherwise, when we come here, our most filled up staircase level was at j, so we return j, right? So let's run this and see. Voila, it works, right? So let's trace it out and we see, right? We're going to use n is equal to 5 and n is equal to 8. Okay, so we're going to use our code. Okay, so we're going to start with n is equal to 1, right? So we're given n coins, right? So that means that our maximum number of coins is between 1 to 1, right? The maximum number of stairs that we can build is between 1 to 1, right? Because the maximum number of stairs you can build with n coins is less than or equal to n, right? So we initialize our I to 1 and our j to 1, right? So our I and j here are initialized to 1. And our interval for the possible number of stairs is from 1 to 1. So our I is here, our j is here, right? So while I is less than or equal to, we calculate the mid. So our mid is going to be here, which is I plus j divided by 2. What's 1 plus 1 divided by 2? Our mid is 1. So we'll calculate the number of coins needed to fill up to, right? So the mid pointer we're at is, let's say here, right? So the maximum number of coins in the code, the maximum number of coins needed to create a staircase of level 1. Remember, our mid signifies the staircase level. So the number of coins, num coins, using Gauss's formula is 1 into 1 plus 1 divided by, actually, n into 1 plus n divided by 2. So this will be 1 into 1 plus 1 divided by 2, which will give us, this cancels out with this, 1, right? So the number of coins is 1. Then we check. If num coins is equal to 1, is num coins equal to, in other words, is 1 equal to 1? Yes, it is, right? Is it less than, is less than, is num coins less than n? No, it's not. Is num coins greater than n? No, it's not, right? So we terminate at this point. And essentially what we've said is that with one coin, right? With one coin, we can only build one stair. So it terminates at this point, and you return mid. right? So let's do it for n is equal to 5. So we're gonna erase these, but we'll keep those other parts. So our n is equal to 5. So we know the maximum number of stairs you can build with 5 coins is between 1 to 5. So this will be 1, 2, 3, 4. So you can maybe build 1 or 2 or 3 or 4 or 5 stairs. 5 numbers of stairs, right? So we go into our code, we initialize our pointers I and j. So our I is here, our j is here. So while binary search, so while I is less than or equal to j, right? Because our I is 1, our j is 5. We calculate the midpoint for the number of stairs. Mid will be here. This is the code. It will be 1 plus 5 divided by 2, which gives us 3. So our mid, let me just move this a bit here. So our mid is here. So we're asking ourselves, can we build 3 stairs with the number of coins we have? So we have to calculate the number of coins needed to fill up 3 levels of stairs, right? How many coins do we need to fill up 3 levels of stairs? It will be using Gauss's formula, n into n plus 1 divided by 2, which is 3 into 3 plus 1 divided by 2. This evaluates to 4, becomes 2, 6 coins, right? We need 6 coins, 1, 2, 3, 4, 5, 6, right? So the number of coins needed is 6, right? So we check. Is number of coins equal to 6? No. Is number of coins less than 5? Is number of coins equal to 5? No. Is number of coins less than 5? No. Number of coins is greater than 5 because it's 6. So we push our j pointer past mid. So we don't want to even look at these staircases because it means that we can't fill them up, right? So we come back here and we update our j. Our j is now at 2. Our I is still at 1, right? Our mid is going to change. So is I less than or equal to j? Yes, it is. I is 1, j is 2. So we calculate our mid, right? So our mid will be 1 plus 2 divided by 2, which will be 1. So our mid is here, right? So we ask ourselves, how many coins do we need to build a staircase of level 1? Right? So a staircase of level 1 will need, using Gauss's formula, which is 1 into 1 plus 1 divided by 2. This cancels out with this, we get 1. So our number of coins is 1, right? Num coins is 1. So we come here, we check, is num coins equal to 1? I mean equal to 5 because our n is 5? No. Is num coins less than our n, which is 5? Yes, it is. So we push our I past mid, right? We execute this code. Right? That's what I've done in the diagram. So our I is now 1, our j is 1, right? We come back here, we ask ourselves, is I less than or equal to j? Yes, it is. So we come down here, we calculate our mid. Our mid will be 1 plus 1 divided by 2, which will be 1. The num coins that we can make with one staircase is, they're both at 2. Sorry, right? Our I and j are both at 2. So this will be 2 plus 2, which gives us 4. This gives us 2. So our mid is 2, right? So our mid is now at 2. So how many coins do we need to create a staircase of level 2 using Gauss's formula? It will be 2 into 2 plus 1 divided by 2. This 2 cancels out to this. We get 3, right? So we need 3 coins to create a staircase of level 2, as you can see here. 3 coins, right? So we come down here. Is num coins equal to n, where our n is 5? No, it's not. Is num coins less than 5? Yes, it is. So we push our I past mid. So it comes here, right? And then we erase our mid. Our I is now at 3. Our j is at 2. We come back here in the code. So I is less than or equal to j. Does not work out because I is now 3 and j is 2. So this terminates and we return 2. So we can, with 5 coins, we can fill up to 2, a level of 2, because at level 1 we'll use 1 coin, at level 2 we'll use 2 coins, at level 3 we'll use 2 coins, and it won't be filled up, right? So that is the binary, this is the log n time solution, right? It's tricky. It's a math tricky question. If you're able to do it in n time, then yeah, but this is a tricky question which involves math. So, all right, thank you. This is the solution. It's a constant time log n space. Log n time constant space. Sorry. So yes, that's it, and bye.